So in this section, I'm going to begin our discussion of Lewis structures and how they work, and how we take the molecular formula or structure and then convert that to a Lewis structure. Now, this section 4.2 is from the textbook, the Smith textbook, and so I will be just kind of going along with how they explain this. Please bear in mind as we go through it, I may go through a little quickly. You can always back this up and look at it again. If this is how you learned it or if this is your preferred way of doing it, it's up to you. But in the next section, I'm going to talk about exceptions to the Lewis structures, and I'm also going to talk about the NASB method, which I think is a little easier to understand. So the molecular formula shows how many of each atom you have and which atom it is. And so it doesn't tell us, though, how they're bonded together. So the Lewis structure takes that one step further and shows how those atoms are connected, and they're connected based on their valence bonds. So the general rules for drawing Lewis structures: you draw only the valence electrons, and you remember you can get those from the group numbers. You give every main group element except for hydrogen an octet. So everybody needs to have 8 electrons except for hydrogen. Then you give each hydrogen 2 electrons. Make sure that they have 2 electrons, or they're at least sharing 2 electrons. So the first thing you do is you're going to arrange the atoms in the order that you think that they would bond together. Remember that carbon is in group 4, and carbon can form 4 bonds. That's why it's so wonderful in making all of our organic molecules that are part of our body. And so if we're looking at CH4 as an example, we have carbon is going to be the center, okay, because hydrogen can't be the center because it can only have 2 electrons, so it couldn't connect to more than one thing. So it couldn't do this, right? It couldn't do this because then that would be counting 4 electrons for this particular hydrogen. So that can't work. So we would draw it like this. For CH5N, usually you could draw it like this to the N, and then N and H. And again, because you can't place the hydrogens in different places. You couldn't do this necessarily because then carbon wouldn't have enough bonds, and so it's just, there are different ways that you have to figure out how to arrange these. And again, these are some of the things I don't like about the way the book shows you to do this, okay? So after you've figured out how they're going to go together, then you're going to count the valence electrons. And the number of valence electrons is equal to the group number. So each carbon's in group 4. So it's going to have 4. And so we're looking at this particular example, CH3Cl. So we have 1 carbon times 4 electrons is 4. We have 3 hydrogens. Each hydrogen has 1 valence, so that's 3. And we have 1 chlorine, and each chlorine has 7 because it's in group 7, so that's 7. And when we add those all together, we get 14 valence electrons. Okay, so that's the total valence electrons for CH3Cl. You place 1 bond between every atom and the next atom. And for the main group atoms, you can't have more than 8 electrons, and for hydrogen, you can't have more than 2 electrons. And then you use all the remaining electrons to fill the octet with lone pairs, beginning with the atoms that are on the outside, not the center atom. So you've got 1, 2, 3, 4 bonds, right? And that's 8 electrons. And then you've got 14 total, so that means that you would put 6 more on the chlorine, and that's where they would go, okay? So it doesn't have an octet, so that's why it gets the 6. You would use multiple bonds to fill octets if you still have some left over. So one lone pair of electrons can be converted into a bonding pair of electrons if you need two more to do that. So for example, a double bond has 4 electrons in it, so it has two electron bonds. A triple bond would have 3 of those 2 electron bonds, and so sometimes we have to do that to use those correctly. So if you have a structure that's got multiple bonds, and we're using C2H4, so we draw the skeleton like we believe it would be because the hydrogens cannot be connected together. Okay, and so then we count valence electrons. We have 2 carbons, so 2 times 4, because that's in group 4, is 8. And then we have 1, 2, 3, 4 hydrogens, and each hydrogen has 1 electron, so that's 4. So I have a total of 12 valence electrons. Then I'm going to put the bonds in between each 2 atoms. So 1, 2, 3, 4, 5. So 5 bonds times 2 electrons is 10. So I have 2 electrons left over. Okay. Now, if I put those 2 electrons there, that would satisfy that carbon. But what about this one? It only has 6 electrons. So since carbon is not going to have a complete octet, then I'm going to have to use those electrons to form a double bond so that both of them have an octet. So now this carbon has 1, 2, 3, 4 bonds, and this carbon has 1, 2, 3, 4. Because remember, those shared bonds, each one of them thinks they actually own those. And so now each carbon, through the sharing and the use of a double bond, actually has 8 electrons, which is what we want, to have that octet. Okay, and so that is the method that the book is showing you on how to put these together.